This video is going to be checking network communications with the Picoscope, and specifically I'm going to be checking CAN data. Now if you remember, CAN is controller area network, and it works off of a high and a low signal, so I'm going to have to use two channels on the oscilloscope, and I'm going to show you a couple of different ways to do it. So the first one is going to be the breakout box, and that's probably one of the easier ways to do this test. So we'll go ahead and get started. This is the breakout box that this is made by OTC, and it works really easily. It's got a DLC connector, so it's the same style connector that you plug the scan tool in. So you just plug this into the DLC, and this is where we can hook up our scope. And these are pinned the same as the DLC connector pins. And the vehicle we're going to be using is the Chevy HHR. And on this one, I looked up the specifications for it, and CAN data communicates on pin 6 and pin 14. So pin 6 is the CAN high, and pin 14 is the CAN low. And then we'll also need a chassis ground, which is right up here. So let's go ahead and plug this in, and then I'll show you the setup. I've got the breakout box sitting on the front seat of the vehicle here, and I've got the DLC plugged in right there. And if you come around here to the breakout box, you can see the pins. So I've got channel A is plugged in to pin 6, channel B is plugged into pin 14, and both of my grounds are stacked on top of each other on the chassis ground. So those are my hookups. Now let's go to the software, and oh, by the way, before I go to the software, you do have to be right around 12 volts. If your voltage drops too low, then this breakout box tends to beep at you and it won't do the test. So you do need to make sure that your battery is fairly close to a full charge. It doesn't have to be 100%, but it does need to be close. So on this capture, I am going to use the automotive drop down. So I'm going to come up here to the automotive drop down, and I'm going to come down here to, it says communication networks, and I'm going to go to CAN high and CAN low, and that'll bring up the sample screen. It shows you what you should see. And then this right here, if you forget how to do this test, just read through these instructions right here. It walks you right through it. Makes it really simple. So I'm going to minimize this page, and this is what we should see. So this should be the CAN high, this should be the CAN low. They should pretty much mirror each other if everything is functioning the way it should. So what I'm going to do is I'm going to go ahead and start the capture, and then I'm going to turn the key on, and we'll see what happens. Okay, so I stopped the capture and I'm analyzing it, and so what I'm looking for is I'm looking for consistency with the patterns, and it looks like everything is functioning the way it should. So CAN high and CAN low are talking to each other. You can see the voltage over here. So this goes down to about 1 volt and up as high as 3.5 volts. And so if you remember from that chapter, if you've watched the chapter lecture on network communications and stuff, this is normal. So the high CAN goes from, it usually fluctuates somewhere between 2 and 3.5, so it goes up and down like this, and then the low goes from 2 down to 1 volt, sometimes 1.3 or 1.4 volts. So, and then I've got a couple of little spikes here, and the spikes, all that is noise on the system right now. So, and it could be because my battery is just a little bit low. It's 12 volts, it's not 12.6. And I've got a jumper battery hooked up on it so that it will stabilize and so that I can get a good reading. So that's using the breakout box. So it's pretty simple, not a very hard test. Okay, this next part, I'm going to show you how to do the same test, only without the breakout box. And all we're going to do is probe the same terminals in the DLC that we did before. So we're just not using a breakout box on this one. So I'm going to take you down inside here, and you can see where I've got my terminals hooked up. So if we look right down in here, see if I can get my camera positioned right. Okay, on the DLC, I've got I'm going to point with a screwdriver so you can kind of see. So I've got the channel A in pin 6, and channel B is in pin 14. And then I've got my chassis ground. I've got the wires going up to the engine compartment. I've got them hooked right there to the chassis ground. So which actually happens to be the cable for the battery that I've got hooked up to keep the battery from going dead. So now what I'm going to do is I'm going to start the trace, and I'm going to turn the key on and capture the communication. So the trace is started. There we go. So this is the same, and it looks very similar to what we got with the breakout box. So this is just another way of doing it without the use of a breakout box. The breakout box is kind of a little bit easier, but this really isn't that bad. So as far as network communications, all you really need to do is figure out, are my modules communicating on the network? And if they are, great. If they're not, then you got to figure out why. But to see if there's any communication to start with, so if you have, say, a no start condition and you want to see if it's a network problem, this is a good test to do. So you just probe pins 6 and 14 for CAN data, and for class 2 and UART, they're different. So in your textbook, it'll give you the pin numbers for class 2 and UART data, but it's done the same way. So you can just probe it, or you can use this breakout box on the DLC to look at it with the oscilloscope. So hopefully this helps. We'll see you in the next video.